Hello? Can you hear me all right? Awesome. So, hi, my name is Hsin-Liu from the MIT Media Lab, and this work was conducted during my internship at Microsoft Research with my colleagues Bichlien, Nguyen, and Asta Roseway, you're right over there, and also Michael Dickey. And I'm here to present EarthTones, chemical sensing powders to detect and display environmental hazards through color variation. And so we think it is an innate human fascination and desire to use the materials around us to edit our physical bodies and how we look. And this has been apparent throughout time and also across various different cultures all around the world. And today, when we look at technology, we really see it as an emerging new material which we can play with our physical identities. And the field of wearable computing since its inception 30 years ago has been playing with technologies next to our bodies, on our bodies, and even now moving inside our bodies. And especially in our research practice, we're interested in looking at interfaces situated directly on the body surface. And looking at interfaces directly on the body surface, they often come in form factors of cosmetic extensions, such as nail art or hair extensions, and very recently moving directly onto the skin. So for instance, tattoo skin overlays or even makeup overlays. And so in our work, we are interested in pushing this boundary to an experience and a form factor that would offer an even more seamless wearable experience. We're interested in a very primitive and you could say basic form factor of powders or pigments, and exploring how we can augment this with technology so it can also display information. And so in our work, we are questioning whether cosmetic powders can be created to become both a sensor and an actuator. We also want to question whether the traditional passive practice of decorating our bodies with cosmetic powders can be augmented to become an active user experience and to be extended into everyday user interaction. So our work relates to an emerging stream of wearable displays, moving from the digital to the purely analog. And so digital displays and human-computer interaction include head-mounted, wrist and finger-rolled LED textiles. There's a lot we've seen in this conference. But there's also an emerging trend of hybrid displays, which are partly chemical or biological and partly electronic in composition. And in our work, we're interested in pushing towards a purely analog display, so without any electronics, for even more seamless wearable experience. And so we're really questioning, so human-computer interaction often has this feedback loop of sensors as input, the brain microcontroller, and then generating output through actuators. And actually very similar in human-chemical interaction, which we would like to introduce in this work, we look at these molecules around us also as input, so let's say environmental pollutants. And when they are sensed by a chemical sensor, there's first an active layer that detects and senses these pollutants. And it then transfers this to a transducer layer, which can then generate an output. So for example, a color change. And specifically, the hybrid wearable displays we're very inspired by include the L'Oreal My UV patch and Biologic. But in EarthTones, we would like to move towards a purely analog display without any electronic components. We're also very inspired by the fashion industry because they're experts in expression through the human body. But however, moving beyond pure aesthetic or playful purposes, we want to extend these displays into everyday user interaction. In EarthTones, we want to offer 3 different types of experiences to display the unseen in our everyday environments. So the first is chemical sensing powders to detect and display carbon monoxide. The second is UV rays, and the third is ozone. So first, introducing carbon monoxide. So carbon monoxide is a colorless, odorless, and tasteless gas. It can occur indoors due to leaky appliances, but also outdoors due to vehicle exhausts. And so it can cause a lot of irritation in our respiratory systems, and it can also be fatal in more extreme cases. And the experience we wanted to offer was a saturation color change that could inform the wearer of elevated levels of carbon monoxide. And the theory of operation, so don't get scared. This is the chemistry part. Yeah, but we're basically using a palladium-2 complex. So it's like the orange blob you see on the left. And what happens is when there's carbon monoxide next to it, carbon monoxide is very oxygen hungry. So what it will do is it will steal an oxygen from the palladium-2 complex, and this will cause it to have a color change from yellow to black. And in our actual implementation, to make these powders more aesthetically pleasing, so they would be desirable to wear, we incorporated them with different makeup color tones to also offer more possibilities for aesthetic customization. And to evaluate the performance of our powders, we expose these powders to varying amounts of carbon monoxide concentration with increased 10-minute intervals. And we can see with 60 ppm being a dangerous level of CO, within an onset of 20 minutes, there's a visible color change to inform the wearer of elevated levels. The second experience we'd like to introduce is ultraviolet rays. UV rays are a form of electromagnetic wavelength that is beneath visible light, but it has high energy. And so in mild cases, it causes sunburn, like I'm sure we've all experienced that before, but in more severe cases, it can alter the composition of our DNA and result in skin cancer. And the experience we would like to offer is a spectrum color change from yellow to orange and gradually to a darker purple color, and to inform the wearer of accumulated UV levels throughout the day. And so the theory of operation for UV is a two-layer component. The first layer is an active layer, comprised mostly of a UV acid generator. This generator, when in contact with UV rays, it will generate a lot of extra acid. And this acid then feeds into the second transducer layer, which is mostly comprised of a pH-sensitive dye. And this pH-sensitive dye will then generate a corresponding color change spectrum, which you can see in this little clip that we have here. So it's sped up. So it goes from yellow to orange, and then gradually to a dark purple. So also to understand the performance of these UV powders, we took powders and exposed them to 0 hours, 1 hour, and 4 hours of UV rays. We then put them under a UV spectrometer and generated this absorbance diagram on the left. And the results show that there is an increase in absorbance level between the 550 and 650 wavelength, as you can see in the red box. And this refers to a red-orangey color change as presented through our results. The third experience we would like to offer is ozone. So there's two kinds of ozone. There's atmospheric ozone, that kind is great, we want that, but there's also ground level ozone, which is often a result of a lot of different environmental pollutants in reaction to sunlight. And this can result in irritation also in our respiratory systems, but long term it can cause asthma attacks. And the experience we wanted to offer was a invisible to visible color change, a opacity color change to inform the wearer of the presence of ozone. And so how does this work? So we're using a potassium iodine complex, and when it reacts with ozone, what it does is it oxidizes and it generates a iodine. And the iodine then reacts with starch and generates a blue to purple complex, and this is a color change that we're getting. And these are our results. So we can see at 0 hours, it's a kind of transparent milky white, but when it's exposed to 24 hours, it turns to this kind of tan orangey look, but with longer exposure, it then turns to the purple-ish color tone induced by the starch reacting with the iodine. So we wanted to understand preliminary user reactions towards such a device, a purely analog device. And so we conducted a 1-hour semi-structured interview with 18 participants. And we first demoed EarthTones to the participants and asked them to wear a skin-safe version that would reflect the color changes. And from our results, first of all, the participants, they saw the powders as a soft and continuous display that it blended in with the body and was less harsh in comparison to traditional digital displays. We also saw a preference for a lot of personalized body locations. So for instance, our female participants who wore makeup on a daily basis, they would still prefer to put this on their face since it could be embedded in an existing habitual practice. But for our female participants who wore no makeup, they preferred arms or legs, different body locations. And our male participants in particular preferred the inner arm or wrist for a more private and conspicuous display of information. They also saw the powders as a very extensible form factor that could be integrated into temporary tattoos, nail polish, lotions, and creams. And they contrasted this to the fixed form factor of a lot of existing wearable devices, such as smartwatches. Participants were also able to distinguish the color changes by eyesight. However, they suggested a possible temporary tattoo legend or, less desirably, a phone app to assist with color detection. And this leads us to discussion of future work. So although it was not indicated a strong preference in our study, we do think it would be helpful to have a phone app with computer vision algorithms to assist with color detection. And this would be especially helpful when these powders are worn in the wild, where there's different amounts of light and environmental factors. And a second part is a front-end software design tool to let participants be able to customize to individualized skin tones and personal preferences. And the software program can also automatically generate the corresponding chemical composition ratio. And also moving towards a skin-safe prototype. So these chemical analog displays, such as ours and also L'Oreal's, they have only started to appear in the recent past year, 2016. And so most of the research effort has been in making the prototypes work, and the verification of the skin safety is still under study. And so as part of our future work is to replace some of our materials with natural and biological compositions for a truly wearable experience. And so in conclusion, we have presented EarthTones, wearable chemical sensing powders which can detect and display environmental hazards. We presented technical evaluations which confirm the performance of the powders, and a preliminary user study which highlighted skin as a very high potential area for analog style. We would like to acknowledge our colleagues Judith Amores for modeling our photos, our mentors Corey Nguyen and Andy Wilson for feedback on our paper, and our study participants for their feedback. So thank you very much. I'll be happy to take questions.
Thank you, Cindy. Can you speak a little bit more about how you would move forward in taking EarthTones chemistry into more traditional computing platforms?
Yeah, so I think this is where like the mobile phone app would really bring back the HCI, the C in this work, like the computer, and to serve as that. But the interesting thing is, like in our user study, the participants actually did not want a phone app to pair Earth because it's like kind of cumbersome. But I think for the sake of, you know, maybe more precise detection, and also when we actually read about this work, because a lot of the reviewer feedback we got was like, this isn't HCI, because there's a missing computer component. So I think that's where kind of like, you know, the phone app would be able to serve that purpose and to bridge back, yeah, to a lot of these concerns, yeah.
So I have a question about the psychology of this kind of an interface in a group. So if I'm talking about putting makeup on my face, that's not an interface for me, it's an interface for another person. And then how does that work if there's a pollutant or a contagion in the environment? Mm-hmm. Is the other person going to associate that with me, or are they going to understand that it's in the environment?
So I think there's like two like perspectives to this, because so first of all, we target these as like wearable powders, so you can put them anywhere on your body, right? So if you put them here, like in your wrist, then it's a more private display for yourself. But like definitely if you put it on your face, then it's a more public display. And it is in a way also a fashion statement, right? Because anything we wear on our bodies is like, it tells something to the rest of the world about ourselves. And so one way about that, it's kind of up to the wearer about, is this something more private for them, or do they want to, also inform the space around them that something is going on, right? And so if you also look at these as more potential for groups of people, when a lot of people are wearing these in an environment, and you start seeing these changes, it can also be like, a very lightweight and interesting way to crowdsource a lot of pollution information that's often like, it seems very far away from the normal wearer.
Thanks.
Yeah, Eric Paulus, UC Berkeley. Thanks, Cindy. Really nice. I like this idea. I'm wondering if you could say some more about the kind of performative nature of it, because you said a little bit about how people place it on their body, but I'm sort of curious, because it is like the last question, the kind of display for others. And so I'm curious if that came out in the interviews about how they wanted to even show it off or do things. And this is slightly counterintuitive because you did this thing around kind of awareness of the environment, but truth be told, someone would want to say like, blow smoke in my face so it'll change and I'll be even more. I mean, they will, it's not the desired effect, but people like to drive systems and they like to drive signals to have effect. So I'm curious if any of that came up.
So I think this, it definitely came up. And so in our user study, we actually found like 3 different groups of people. One was male participants, 6 male participants. So we had 6 female participants who did not wear makeup, and 6 who wore more makeup on a daily basis. And the results we got from especially the group who wore makeup very often, they really wanted to, because recently there's a lot of like environmental friendly fashion, and you also say a lot about your personal values through what you wear, and now even through your own makeup, right? So it said they expressed that it would help them make this statement, and also to just like increase awareness of a lot of these hidden hazards around us. Because before I did this work, like I had no idea like CO, UV, like ozone, like cool, but like I wasn't able to really connect with it, right? But today, if like my office mate, she's wearing that, and it changes every day, then I think that also raises a certain level of awareness. So there's definitely like a very interesting social aspect to this, which I think would be very interesting to do a lot more detailed qualitative or even quantitative user studies on.
Great. Okay.
Thanks.
Hi, Brooke Bribois from Pacific Northwest National Labs. So it sounds like you had a fairly small user group, and I was just curious about the full range of skin tones, because your model is incredibly pale, and how that might appear, some of those color changes, if they even register on like darker skin tones, and how in at least the US makeup industry, darker skin tones are typically underserved and not just forgotten about historically. So just curious about that
that's a very important question, and that's also why in like our future work section, we think it would be helpful to have a front-end software tool where you can personalize the right color tones for your skin tone, but also your aesthetic preference.